Hello everyone. On this video we will be going over parametric equations. Okay, so starting off we will give you kind of a general idea of when parametric equations are used. Okay, so they are useful when you're describing a curve that might or might not be a function. Okay, you can actually use them for both. Okay, so one thing you know is that parametric curves have a direction where x, we change that to some function of t, and we do the same thing with y. Y is equal to some function of t. And they are called your parametric equations. Where t is your parameter. Okay, so in other words, you can look at it as an xy graph or xy equation is now turned into an equation with a new variable, t. Okay, and using that new variable, so I can kind of give you a visual as to what a parametric curve would look like. Okay, so that's your x, that's your y-axis right there. That could be a parametric curve. Or we have our x and we have our y. That could be a parametric curve. Okay, so let's go with one more just to kind of reinforce the idea. We have our x and we have our y. Let's say that could be a parametric curve. Okay, now if you notice, out of these three, the first one is the only one that's actually a function. Okay, how do we know? Because this is the only one that would pass the vertical line test. Remember from either pre-calc or even intermediate algebra, your vertical line test, you draw a vertical line. If it crosses the graph only once, then it's a function. You notice here, if you draw a vertical line, it crosses the graph more than once. Same thing here, if you draw a vertical line, crosses the graph more than once. So these two are not functions. This is a function, but they are all parametric equations. Okay, so a little tidbit here. As t changes, your x comma y, which is now equal to some function of t and another function of t, that also changes and gives us our parametric curve. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and go to our first example. Okay, so for example, let's say if we wanted to sketch the curve defined by the parametric equations let's say x equals 1 plus square root of t, and y equals t squared minus 4t. Let's put limitations on the value. Let's say t can be between 0 and 4. Alright, so there are a couple of ways you can actually sketch this, but I found the easiest would be to start with what we call a t-chart. Okay, so start with a t-chart. Okay, and that is basically just a chart where you have your t, you have your x, and you have your y. Okay, so what we're going to do is we're going to get various values of t that's actually within our restrictions. So in this case, it's restricted between 0 and 4. Okay, so we're going to make it equal 0, 1, and 4. And I picked those values because they're perfect squares, and we have a square root there, so it kind of makes things a little bit easier. Okay, so now we plug in our t equals 0 to get our x and our y. So when t is equal to 0, 1 plus square root of 0 is just 1 plus 0. So x is equal to 1. We plug in t equals 0 y. 0 squared minus 4 times 0 is just 0. So we end up with 0. So that means our ordered pair f of t, g of t, this one just becomes 1, 0. Because remember, this is no different than our x, y. Okay? Same thing when t equals 1. When t equals 1, 1 plus square root of 1 is 2. So x is equal to 2. When t equals 1, you have 1 squared, which is 1, minus 4 times 1, which is 4. So 1 minus 4 is negative 3. So you get the ordered pair to negative 3. Okay, here you have your t equals 4. 1 plus square root of 4, or 1 plus 2, would just be 3. Same thing here, you have your 4, so 4 squared is 16, minus 4 times 4, so you end up with 16 minus 16, which is 0. So you have 3, 0. Okay, so once you fill in your t-chart, you just plot those points on your regular XY graph. Okay, so go ahead and create our XY axis. We have our X and we have our Y. Okay, so t equals 0 in this case is our initial point. So we have 1, 0, which we'll post right there. So that's our 1, 0. We have 2, negative 3, which we'll put right there. So this is our 2, negative 3. And then we have 3, 0. And we'll put that right there for our 3, 0. So we see here that our graph would kind of look like this. Okay, so where t equals 0, this is what you call your initial point. Okay, so from there, we can see that starting from your initial point, as t increases, that's where you're going to draw your arrow in the direction that t is actually getting bigger. So when t is equal to 0, you're starting there. Then t is equal to 1, which means you're going to go from your initial point to this point. T equals 4. So if you had t equals a bigger number, it would keep on going. All right, so let's make that quick note. As t increases, the curve moves in the direction of the arrow. Okay, and that is your sketch. Okay. So if you are still writing, feel free to press pause, but we're going to go ahead and go to our next example. Okay, so let's say for this example, if we wanted to sketch x equals square root of t and y equals 1 minus t. Okay. Now with this one, this is actually the question, which is a little different before because you notice there are no restrictions. They don't tell you t has to be between one value and another value. This is all they give you. Okay. Now with this one, you kind of create your own restrictions. So you just have to look and say, okay, what are the restrictions I'm going to use? I kind of use the square root for this problem as a guide. It may be different for another problem, but for this problem, I use the square root as a guide. Okay, so no restrictions are given. Nope, for t. Let me make sure that little tidbit of information in there are given for t. But since x equals the square root of t, just assume that t is greater than or equal to 0. Okay? Because most of our, well, not most, all of our answers are usually put into real numbers. We're not looking for complex numbers. So we just assume that t is greater than or equal to 0. Okay, so what I want you to do, I want you to press pause and try to sketch this one on your own using the same steps from the previous example. Okay, so go ahead and press pause and do this one. All right, so assuming you press pause and you work this one out already, go ahead and verify your answer. Okay, so again, when you're going to sketch a parametric curve, of course you start with your t-chart. Okay, you have your t, you have your x, and you have your y. And fill out a few spaces here. Again, because of the square root, decide to pick perfect squares. You have 0, 1, 4, and 9. Okay, so if we plug in t equals 0, square root of 0 is 0, so x is equal to 0. Plug in t equals 0, 1 minus 0 is 1. So that gives us the ordered pair of 0, 1. Same thing here, t equals 1, square root of 1 is 1. Here, t is equal to 1, 1 minus 1 is 0, which gives us the ordered pair of 1, 0. Okay, t equals 4, square root of 4 is 2. T equals 4 here, 1 minus 4 is negative 3. Okay, same thing here with 9. Square root of 9 is 3. 1 minus 9 is negative 8. Okay, so we have our ordered pair of 2, negative 3, and of 3, negative 8. Okay, so we have all the ordered pairs that we need. in order to graph this parametric curve. Okay, so we go ahead and we draw our XY axis. We have our X and we have our Y. Okay, so let's say our first point, 0, 1. That's about right there. So let's say 0, 1. And our second point, 1, 0. So that one we can put about right there. Okay. Our third point, 2, negative 3. So let's say 2, negative 3. And let's say our next point, or our last point, is 3, negative 8. Say 3. Let me draw this out a little bit further. And make this a little further down. And 3, negative 8 is about right there. Don't really know why I filled that one in there. There we go. So this is our 3, negative 8. And we just go ahead and connect those. That should have been more than of a curve, so I'm going to move this over just a smidgen, just to make it look more like the way it should. Okay, so there we go. So it should look more like that. Okay. Now, if you remember, for a parametric curve, we have to know the direction. This is our initial point. So we know as t gets bigger, the curve goes in this direction. Okay, so this is the sketch of the two parametric curves. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and go to our next example. And the next example looks at eliminating the parameter. Okay. Now, if you remember, for a parametric curve, the parameter is your t. So basically, you're eliminating the t. Okay. So to do that, you remember you have the option of solving the x equation for t and substituting that into the y equation. Okay. Now this is called eliminating the parameter. Eliminating the parameter. Okay. And actually is not as confusing as that would make it seem. It's pretty straightforward. Okay, so let me give you a quick sketch. Okay, so using the very same parametric equations from before, this time we'll sketch x equals square root of t and y equals 1 minus t by eliminating the parameters. All right. So to eliminate the parameters, remember, you have to solve the x equation for x. So we have x equals square root t. So if we square both sides, we square this side and we square this side, we end up with x squared equals t, or t equals x squared. I just figured I'd flip that around. So t equals x squared. Okay, since the exponent and square root cancel each other out. Okay, now with the y equals 1 minus t, since t is equal to x squared, that gives you y equals 1 minus x squared. Okay, so in other words, you have your y as a function of t. Now y is equal to some function of x. So we'll call that g hat of x. So instead of g of t, is g hat of x. Or you could put another variable. Doesn't matter. Just kind of use g hat to keep it all together. Okay, so if we graph 1 minus x squared, we end up with this in particular. So you have your x and you have your y, and 1 minus x squared kind of looks like this. So y equals 1 minus x squared. Okay, so going back, I'm just going to cover this up for a quick second. If you notice, you block the left half of this graph, it kind of looks like our first graph. The only difference is when you eliminate the parameter, you don't have any direction. When you have your parameter, you know exactly which direction you're going from the initial point. But overall, the graph itself looks kind of the same. All right, so if you are still writing, please feel free to press pause. But we're going to go ahead and go to our next example. Okay, so for this one, if a curve on a plane is described by the parametric equation or parametric equations, x equals 1 plus sine of t, and y equals negative 2 plus cosine of t. Okay, so for part A of this problem, what point on the plane corresponds to t equals pi over 2? And for part B of this question, what is the equation and shape for xy as t increases? Okay, so what I want you to do, I'm going to give you a hint for B, but I want you to try this one on your own. But before you do, for part B, the hint I'm going to give you is solve for sine of t and cosine of t to start. Okay, so go ahead and press pause, and I want you to try and solve this one on your own. Alright, so assuming that you've already solved this one, let's go ahead and verify your answer. So, put the solution there. Okay, now for A, if you actually just plugged in pi over 2, you did the right thing. Okay, so x equals 1 plus sine of t means that x equals 1 plus sine of pi over 2. Since sine of pi over 2 is 1, that gives you x equals 1 plus 1, or just x equals 2. Okay, so let's go with y. Y equals negative 2 plus cosine t. Replacing that with pi over 2 plus cosine pi over 2. Cosine of pi over 2 is equal to 0. So y equals negative 2 plus 0, or just y equals negative 2. Okay, so 2, negative 2 is your corresponding point. Okay, so that's how you solve A. And we're running out of room, so we're going to pick this one up on the next page. So if you are still writing, feel free to press pause. But we're going to go ahead and move to the next page for B. All right, so we'll continue that. So for problem B, remember we have x equals 1 plus sine of t, and y equals negative 2 plus cosine of t. So remember the hint that I gave you, to solve for sine of t, so we subtract 1 from both sides. So sine of t is equal to x minus 1. Here, if we add 2 to both sides, we see that cosine of t is equal to y plus 2. Okay. So if you don't know where to go from here, don't feel bad. You have to kind of go back to your intermediate algebra or pre-calc formulas. So if you remember, sine squared of t plus cosine squared of t is equal to 1. Actually, I think that's trig, not pre-calc. So that means sine squared is just x minus 1 squared. So you have x minus 1 squared plus cosine squared is just y plus 2 squared equals 1, which we'll put as 1 squared. Okay, so going back, now this you probably remember from your pre-calc or intermediate algebra. It's x minus h squared plus y minus k squared equals your radius squared is the equation of a circle. Okay, so that is a circle with the center equal to hk and radius equal to whatever the r is. Okay, so that means if we get our equation, rewrite it as x minus 1 squared plus, instead of y plus 2, we have y minus negative 2 squared equals 1 squared. It matches up with the formula. Okay, so actually, our parametric equations gave us the graph of a circle. Okay, so in this case, the center is 1, negative 2, since that's your hk. And the radius, at 1 squared, so our r is equal to 1. Okay, so that means if we sketch this parametric curve, this is our x and this is our y, and our center is at 1, negative 2, so that would be, put that right there. So this is 1, negative 2. Actually, that should have touched that, but you get the idea. So our radius is 1. And again, that should have touched that, but instead of erasing the circle, it'll just be easier to erase the y-axis. There we go. Okay, so r equals 1 is your radius, and this is a sketch of our parametric curve. Okay, so every once in a while, those old trigonometry and intermediate algebra formulas will pop up. So you do have to kind of think outside the box a little bit. All right. So hopefully this made sense, and I will see you on the next video.